And this we are going to see about pointing vectors. So it is a vector quantity that represents the flow of energy in electromagnetic waves. So it represents the flow where the direction flows is represent it's a pointing vector. It's simply where the charge the vector quantity will point the flow of charge, that is called a pointing vector. So it is also we can also say that that is a cross product of electric and magnetic fields. Is simply if you are having a conductor in that if electric field is traveling in the side, so around this conductor we will have a magnetic field. So here the cross product, this cross product of electric and magnetic field of electromagnetic waves. Okay, so we know that we are having a seven electromagnetic waves in that they are mentioning that. So here we are taking pointing vector as s. So s is equal to 1 by mu. Mu we know that permeability, it is a permeability. So permeability, we didn't mention. Okay, permeability, and from the previous explanation, we know that this is electric field and the magnetic field. So E is electric field is represented as E, and magnetic field is represented as B. So it unit, obviously we know that Weber per meter square. So we are having magnetic field. So we take Weber and meter square. So when we are talking about the length, we will take meter square. So it is a wave propagation. So the wave will propagate in the conductor or anything we will say. Okay. So again we are writing for the free space. So this is a pointing vector. We putting the vector here. So 1 divided by mu naught. Mu naught is a permeability of free space. Permeability of free space. Okay. So here the E cap is a electric field vector and B is a magnetic field vector. So we know that next we are going to see this A square, that is Armstrong square divided by N square, that is N Newton by Coulomb. So Newton will get minus A minus M. So C by S, N by S. So we will get the Weber per meter square. So simply we can come to the calculation. So N we will take here pointing meter S is equal to N. Okay. So just we take n is equal to 1 divided by mu cross eb. So we know that delta we can take as the delta. So okay, delta is equal to e cross b, that we can simply cross with the e delta cross b and delta cross b. We can simply into two times with respect to b. With respect to b we will take e cross delta. So here, so with respect to E, we can take delta cross B. So simply we will put the delta value. So dou B by dou T is equal to dou epsilon naught mu by. So we are having here mu naught. So mu naught epsilon E by Et. So rearranging with E one side and B one side, we will get this equation. That is delta E cross B is equal to minus B dou B divided by dou T epsilon naught mu naught E cross D by dt. So b d by dt is equal to of dou by dou t b into b cross. So this b cross, this both b cross will get here. So we will get dou by dou t half b square. So delta is equal to e cross h dou by dou t half epsilon naught e square mod e square half epsilon to a square. So simplifying this, we will get the answer du by dt. So where we will put j. So j is represented as a charge flow. So here the charge will flow in this action, though. So this is the represented as j. So we will get the final equation as n is equal to e cross p. N we know that it is a pointing vector. E we know that it is a electric field pointing vector. So h, what is h? It is a horizontal component of earth. Okay. Thank you.